Welcome to the next video of Chapter 6, which covers dividing polynomials. Earlier, we looked at multiplying, adding, and subtracting polynomials. So today we'll do division. We are going to divide a polynomial by a monomial, and we will also divide a polynomial by another polynomial. We're going to start out with some vocab before we look at an example. So these are some terms that you probably have heard before, but it might have been a bit since you've heard them. The dividend is the number that's being divided. The divisor is what you are dividing by. The quotient is the number of times the divisor goes in. And the remainder is what's left. So I know the definitions are a little bit more wordy than that, but when we get into a few examples, I'll point out each of these to you. So if we look at 1a, what's in the numerator is called the dividend. What's in the denominator is the divisor. So the numerator is being divided by the denominator. The dividend is being divided by the divisor. Now, this vocab is not something I'm going to ask you again, so please do not worry about memorizing this. Here's the general idea here. We have 3 terms in the numerator. Each term is divided by 5b. So we'll divide the first term by 5b, the second term by 5b, and the third term by 5b. What I'm going to suggest then is we break this up into 3 separate fractions, one for each of those terms in the numerator. So I have 5a squared b over 5ab minus 15ab cubed over 5ab plus 10a cubed b squared over 5ab. And now this is just exponent properties, what we did at the beginning of the chapter. In the first fraction, those 5's cancel out, and the b's cancel out. A squared divided by a is just a. In our next fraction, 15 divided by 5 is 3. Those a's cancel. And then b cubed divided by b. Well, remember that b in the denominator has a 1, and you are subtracting the exponents. So we get b squared. And then the last term, 10 divided by 5 is 2. A cubed divided by a, that a in the denominator has a 1. So 3 subtract 1 will give us a squared. And then b squared divided by b, again this is b to the first. Subtract those exponents and you get b to the first again. Now, I can write that one or I don't have to, doesn't really matter. And that's my answer. This answer that I got is called the quotient. There's no remainder in this case. Everything was divided by 5ab, so no remainder. You're only going to have a remainder when you have terms that can't be divided by 5ab. Okay, let's look at example B. If we look at example B, we're going to notice that this one looks different. It doesn't even look like dividing anymore. Well, let's think about what that negative exponent means. Negative exponent means to move it. So this term is really 1 over 3xy. We moved the 3xy to the denominator. Now, if I'm going to multiply what I have by that 1 over 3xy, I get 18x squared y plus 27x cubed yz squared, and then that 3xy is in the denominator. Now it looks similar to what we did in part A. Again, what's being divided is called the dividend. What's doing the dividing is called the divisor. So again, we have 2 terms, both of which need to be divided by 3xy. So like we did earlier, we're going to split those 2 terms up. We get 18x squared y over 3xy. Then we get 27x cubed yz squared over 3xy. And now we're going to simplify the 2 fractions separately. First fraction, 18 divided by 3 is going to give me 6. X squared over x to the first is x to the first. Remember, we're subtracting. And then those y's cancel each other out. Bring down the addition. Next one, we're going to do 27 divided by 3, which is 9. X cubed divided by x to the first is x squared. Those y's again cancel each other out. There's no z in the denominator, so we get to keep that z squared. And again, whatever we get as our answer is called the quotient. No remainder again, because everything was divided by 3xy. There's nothing left over. So that is the first type of division that we are doing. That is when you are dividing by a monomial. So let's write that. This is the process for dividing by a monomial. By monomial, I mean that there's only one term. All right, 3xy is one term, 5ab is one term. If there was addition or subtraction, that would be more than one term in the denominator. So now we're going to move on to the other type of division, which is when you're dividing by a polynomial, more than one term in the denominator. So let's see what that looks like. Next type of division we're doing is what's called synthetic division. So we see that example at the top. We're doing x cubed minus 4x squared plus 6x minus 4 divided by x minus 2. Okay, this is different than what we've seen before. In this case, we are dividing by a polynomial. There's two terms, an x and a negative 2. Anytime that you are dividing by a polynomial, you are doing what's called synthetic division. Synthetic division. So it doesn't work for us to just split this problem up. Anytime you're dividing by a polynomial, you cannot split the problem up. Okay, so we have our 4 steps for synthetic division. Step 1, write the coefficients of the dividend so that the degrees of the term are in descending order. Conveniently for us, that's already the case. So we have the third degree first, then the second power, then the first power, and then the constant. Denominator, we're also in descending order. Okay, here's what you're going to do next. This number that you're dividing by, you're putting in the box, but at the opposite sign. So instead of a negative 2, it's going to be a positive 2. Then what you're going to do is you're going to take the coefficients of your terms. So in front of that x squared, it's like there's a 1. It's understood to be there, it's just not written. So we have 1x to the third, negative 4x squared, 6x, and negative 4. Okay, we're still in step 1. It says bring the first coefficient down. So we do. Step 2, multiply the first coefficient by r. So what we're going to do, multiply your coefficient by r, and it goes in the next spot. So 2 times 1 will give me 2. We are then adding down. So we get negative 2. Again, multiply that number by r. We get negative 4. And add down, which is 2. Again, multiply our number by r, put it in the box, and add down. Okay, the only thing left to do is to write this as a final answer. This term is always going to be 1 less than what you started with. So if we started with x cubed, this will be x squared, x, and a constant. We get x squared, 1x squared, minus 2x, plus 2. Last number is the remainder. Our remainder is 0, so we're just going to leave it. That's our final answer. Okay, so I know this process is new and it can be a little confusing, so we are going to do another example together, and then you will do one on your own. Okay, so let's look at, we're actually going to do example 2b together, and then I'm going to have you do 2a. So we know that we're dividing, which is good. Now, we need to be able to recognize when we need to use synthetic division. In this case, the example tells you. On your classwork, on a checkpoint, I'm not going to tell you though. Here's how we know. We are dividing by a polynomial. Anything that is more than one term tells us that we need to use synthetic division. So, anytime that we're dividing by more than one term, we're going to use synthetic division. If we're only dividing by one term like we did on the first page, then you're just splitting into fractions. Okay, setting up synthetic division. We're dividing by a plus 2. You need to put the opposite sign in the box. Then check. Do my terms go in order in terms of the degree? They do. Exponent of 4, then 2, then 1. Okay, so this is a little bit different. What you should notice is that we don't have an a to the third. Right? We have a to the fourth, we have a to the second. That a to the third is really 0. We're going to need that placeholder when we write out our coefficients. So if you remember above, we wrote out the coefficients on each of our terms going in order. So we have 4a to the fourth, 0a cubed, 2a squared, negative 4a, and 12. Like above, bring the first number down, then we start the multiplying. So we'll multiply, put that number here. So 4 times negative 2 will give us negative 8. And then if you remember, you're always adding. Then multiply again. Negative 2 times negative 8 gives us 16. Again, add down. 2 add 16 is 18. Then we get negative 36. Add down, which is negative 40. Negative 2 times negative 40 gives me 80. And then I have 92 here. Now we need to write our answer out. We started with a to the fourth, which means we start 1 degree less down here. So again, a to the fourth is what we started with. So down here starts 1 exponent less, or 1 degree less. So it'll be a cubed, a squared, a constant. This is our remainder. So we have 4a cubed minus 8a squared plus 18a minus 40. Our remainder is what we couldn't divide by that a plus 2. So our remainder is what we couldn't divide by that a plus 2. So it'll be a fraction. This is our final answer. Okay, example 2a you are going to do on your own. I will help you set the problem up though. 2 terms, again, means that you're using synthetic division. This number, you put the opposite in the box. Before we write down our coefficients, make sure our exponents go in order. So we have x cubed, x squared, x constant, they go in order. Are we missing anything? No. So now you can bring down those constants. So we'll bring down the 2, the negative 13, the 26, and the negative 24. This is the part where I'm going to leave you on your own. So you need to finish this problem and turn in your notes. If you want some extra examples, these are optional, they're on the next page. So if you want a few extra examples before you go through this one, please turn to the next page. Okay, so for our first extra example, we got to ask ourselves, do we need synthetic division here? Are we using synthetic division or are we just splitting up? Well, in this case, we are dividing by a polynomial. Again, there's more than one term, which means we are doing synthetic division. b minus 2 means we put a positive 2 in the box. Before we write down the constants, we got to ask, are these in order? Well, we have b to the fourth, b cubed, b, and a constant. So they are. We're missing, though, b squared. So remember, we're going to need that as a placeholder. We have 6b to the fourth, negative 8b cubed, 0b squared, 12b, and negative 14. Okay, so first number comes down. Then you're ready to multiply. So 2 times 6 gives us 12. add down. 2 times 4 gives me 8, add down. Then I get 16, add down. 2 times 28 is 56, add down, and I get 42. Now when we go to write our answer, initially we started with b to the 4th. Our answer will start with 1 less. And we always got to remember that last number is our remainder. So we have 6b cubed plus 4b squared plus 8b, add 28. Our remainder is what we couldn't divide by b minus 2. And b minus 2, remember, is what we're dividing by. Okay, d, again, we're dividing by a polynomial, so we want to use synthetic division. We're going to flip the sign, so a -3 goes in the box. We'll notice our terms go in order. We have x cubed, x squared, x. We're not missing anything, so we're ready to go. We have 2, 3, -4, and 15. So we're going to bring down, multiply, add down, multiply, add down, multiply. So in this case, we have a remainder of 0. Because we started with x cubed, our first term will be 1 less, which is x squared. Remainder of 0 you don't need to include. If you want to, you can always write it like this. That's not necessary though. Hopefully that was helpful. If you have any questions, please make sure you write them down so that you can ask in class, send me an email, or of course come to office hours.